All right, so you've gone through the lecture slides. You've taken a look at some of the examples, right? Some of the syntax for the data types, for variables, for constants, for casting. So now we're ready to put our skills to the test. So this is the lab assignment here. So follow the lab instructions. They might not match this video exactly right. So make sure you follow the actual instructions on the lab. I just kind of want to show you some examples for the lab. Let's say it says declare a variable to store your name called my name, initialize it with your first and last name. So I'm not going to do the assignment for you, right? Of course, that's going to be up to you, but I'm going to show you some similar examples. So I'm going to pretend I'm, creating a social media account. So I'm going to do a few different variables. I'm going to have a variable for, let's see. So I'm going to do variables and I'm going to say account name, or let's say username. Could be all lowercase. We'll say age. We'll say username. We'll say age. We'll say bio, account bio, account biography. Let's see some other values. Let's go with so age, account biography, username. I want to keep it down to like mostly primitives because we haven't covered objects just yet, right? Or other data structures. So let's see username, age, account biography. Let's also go with I don't know. Let's go with best friend. Let's say like you only have one best friend on that social media account, and then let's go number, num followers, and num following, and then let's put average likes. All right, so let's think about each of these variables and let's see what it would look like to declare these. So remember, when you're declaring a variable, first you need the type. So username. There's really only one data type that can store many characters together, and that's a string data type. So I have to start with the type, and then I have to give it a name. Username, I already came up with that name. It's very descriptive. And then let's go with, for example, Professor Bitus. And of course, I always need to end with a semicolon because I'm working with Java. This is not the case for all programming languages. If you're used to like Python, for example, then you're gonna forget your semicolons a lot because Python doesn't need semicolons. All right, so let's go with age. Age. So I copy pasted just because I like to work with the same structure. We're doing this over and over again. We're just gonna be changing type, the name, and the value. So age, what's the data type that makes the most sense for age? Well, if I'm talking about years old, that's a whole number. I could certainly go memory efficient, but honestly, for this class, it's totally fine if you just go with int. Int is so general purpose. Even in my professional programming, I hardly use byte, short or long. I would mostly stick with int. Now, there are cases, right, where you do have to go with a different one, but for the most part, int gets the job done. So I'm going to go int age, and then this is no longer going to be a string. This is going to be a value. Remember, for integer values, these whole number values, unless you're doing a long, all you have to do is type in the value. You don't have to do anything special. So I'm going to say 29. I am 29 at the time of recording this. And let's see, account biography. So that's going to be a string, definitely. So account biography equals professor at LA Harbor College. And then again, I have to end with a semicolon. And then best friend. Best friend, I'm going to get rid of that one, but actually, I'll show you what that might look like. I might have a class for this. It might be called account best friend is equal to, and then I would actually point it to the best friend account. So I could do something like account dot get, and then I might type in like their ID or something. This is a non-primitive. So again, I didn't really want to show you these for these examples. So we're not using non-primitives for this class other than string. Remember, string is technically a non-primitive. But yeah, once we get to classes and stuff, these custom data types, as you can think of them that way, they'll make more sense. So we're going to get rid of best friend. It's good to look at, though. It's good to look ahead. Num followers, again, that's got to be an int. You're probably not going to go with long unless you're like, I don't think anybody's that famous where you need a long value. So int should get the job done. So we're going to go int num followers is equal to, I think these days on my personal account, I probably have like around 400 followers. Nothing crazy. And then int num following, probably have less, maybe like 350. And then average likes. Well, average likes not going to always be a whole number, right? If you're doing division, you're probably going to get into some decimal values. Because I'm not too worried about memory efficiency, I'm going to go with double. I'm more worried about precision. So I'm going to do double average likes is equal to, I don't know, let's go with, let's be generous, say 100.5. A value that falls in between two whole numbers. So yeah, this is how you would declare a variable. If you need to do casting, for example, let's say this int, I changed it into a double, right? So if I want to change it to a double, I could just go double, right? And then it's going to automatically do the casting for me. It'll add the decimal for me when I do an output of it, when I print it out. But let's do this via the variable name. So I'm going to reference this variable. So num followers, I can do a reference to it. So I'm going to do a new variable called int num followers as double equals to num followers. Now I already made a mistake because num followers as double should say double in front, right? Because I'm turning this into a double. Now Java is going to do implicit casting because between doubles and ints, it's not too difficult for it to guess, the conversion. They're both numbers. It's just going to add like a little decimal point to your number. But if you wanted to do this explicitly, you could definitely type in double in front of it. So num follower is originally an int. We're referencing it here, and we're turning it into a double. So that's casting, explicit casting. When you don't do the casting yourself and you let Java do it, that's called implicit casting. You can't cast everything. That's not always possible. So for example, if I try to do char num follower or char num followers as double, let's do an as char is equal to, I don't know, let's go with username. Username is a bigger value, a bigger data type than char. So we can't do this type of conversion. This is invalid. So check it out. It says required type char provided string. And if I try to do explicit casting, char, I'm turning a username into a char, then it'll give me the proper error. Inconvertible types. So this is an example of a casting that you cannot perform. You can't convert a string into a char. It's not possible. Because a string is a bunch of chars together. How can you put that into just a single character, into just a one char? So this conversion, for example, is not possible. So that's an example of explicit casting, turning this username, which is a string, into a char. This one doesn't work. So not all casting is possible. Once we get to classes, you can actually define custom logic for how to cast between different classes. So you decide how the casting is performed. So yeah, that's declaring variables. If I want to make one of these a constant, I throw a final in front. And then of course, by convention, I got to go uppercase. So if my name wasn't going to change, if I'm going to stay forever young and at 29 years old, then I throw a final in front of it and I do an uppercase. Uppercase for the name, just by convention. That uppercase just helps us identify that it is a constant value. Because if I use age somewhere else, for example, if I do int copy of my age equals my age, or sorry, age, then I can see, oh, I assigned a constant to copy of my age. I can tell because I uppercased it. So whenever I use this variable, I reference it in other areas of my code. Because it's uppercase, it'd be pretty obvious to me that it is a constant because I'm following that convention. So yeah, here you're gonna be declaring variables for the lab. You have to decide what's the best type. Sometimes I'll tell you which type to go for. You'll do some explicit casting. Again, more declarations. And then I actually write the code for you here, the prints. And then once you print this out, you're gonna answer a few questions about the code. You know, what was implicit casting, what was explicit. So you do have to actually look through my code here and understand what's going on. We're now equipped to do that. And you know, if you have questions, you can always reach out to me and email me. But everything's on the slides. If you do have like a serious error you can't debug, we can also meet during office hours. But I think for the most part, this lab is more about theory than it is about programming. We're learning, we're getting the all the equipment before we actually start writing our own programs. So yeah, this is kind of like writing your own program though, because you are defining variables, and that's one of the most fundamental things you do in a program is define those variables. So yeah, check it out, run it, and once you get it working, you'll get a cool little output here. Here's an example of what it might look like. Hi, my name was William Biatis. I'm 29 years old. My age in the float type is 29.0. My first initial and the int type is 87, blah, 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 blah. Yeah, there's some questions that'll test your knowledge of what we covered in this week's lesson.